So this will be the second. We'll start the second part of the JavaScript course. In the second part, I'll talk about the document object model and events. So how we can use the previous the first part of presenting of the JavaScript lecture was about features of the JavaScript language independent of HTML files, and the second part of the course will link directly the JavaScript language to HTML files, how we can use JavaScript in HTML files, and the document object model, which allows us through JavaScript code to modify the current HTML document. In addition, at the end of the course, I'll take you through a lot of the examples that are JavaScript examples that are on the course's website. So these examples here. Before we go on, let me just quickly tell you about a mistake I've done in the first part of the course. I had a mistake related to this class specification. I had here for the getters of specialization and for the getter of study year, I had this study year, and I had here specialization. And this doesn't work because it's actually written here, and I've already told you that we cannot use, so the name of the getters and setters cannot be the name of a property like this one. Okay, so property of the current class, which is prefixed with this. So this specialization prefixed with this cannot be the name of this property, because this is just a pseudo property, an alias. So something. So a property, not a real property, but a pseudo property, an alias. So this, the name that is prefixed with this should not be the same name used here. So that's why I need to use here some other name of the property. Okay, and here year. So year is used for the getter, and for the setter the same year. And also for specialization we use spec, and for the setter we use the same spec. So this was the mistake I had in the first part of the course. Okay, let's save this and move on with the presentation. Okay, so we first start with events. Most of the JavaScript code that is executed in the browser is not organized as a main program, but instead is just pieces of code written into functions which are called when an event happens in the browser, like a mouse click, mouse over, a focus lost, and so on. JavaScript is an event-based language. Example of events are key pressed and element losing focus. And when an event is triggered by the browser, as I said, a specified JavaScript code can be executed. Event handlers are associated to a tag like this. So there are 4 ways, but I didn't have enough room to also write the 4th way of assigning a JavaScript code to an event. But you'll see that in the following slides. So we have here a tag like button or whatever, and the event handler for this tag is this JavaScript code that's written here. An event handler here, this one can be on click. For example, when the user clicks this tag, then this code is executed. Or we can have this in the script. In the script tag that is usually written in the head tag of the HTML function of the HTML document, we can have a function like this one. A function like this one, event handle. And this event handle function is specified as the event handler for this tag. Okay, it is just called, actually it's called here with the parameter this. This in our case would be the object corresponding to this tag. You'll see more about this when we talk about DOM, document object model. A third way to specify an object, an event handler for a tag would be this one, where this object would correspond to a tag, and we specify the event handler for this object to be this JavaScript code. Okay, and there's a fourth one using add event listener, but you'll see an example later on. A selective list of events, mostly for desktop environments. There are more events, and a complete list of events you can be found on the W3 schools. The event is abort, and the event handler is on abort. So when an image is stop loading, the abort event happens when a component loses focus, like a window and an element. The on blur event handler takes place. When you change a text area, or the value of a select, the change event happens, the click event happens, the drag and drop for window, key down, key up for document, image, link, and this is the event handler. Mouse down, mouse move, mouse out, moving the window, resize, reset, submit, they are all events. And the event handlers are here. This is the event is applied to this form, text, window, whatever, and the event is generated. For example, mouse down is applied to the whole document, to button, to link, and the event happens when the mouse button is pressed. The left mouse button is pressed. And you can find a complete list of events here. We can insert JavaScript code into an HTML document like this. There are 4 ways. The usual way is by specifying a script tag, which is usually placed in the head tag of the HTML document, but it's not necessary. And then we write JavaScript statements and close the script tag. The second way is to write the JavaScript code in an external file called common.js and include it like this in the current HTML file. The third way, which is least used, is to use JavaScript variables in the HTML specification in the HTML document. For example, here I'm using the value of the bar width variable, JavaScript variable, and here I'm using the value of the my title JavaScript variable. I need to precede it using this and sign and this curly braces here. And the fourth way is to write JavaScript code as an event handler, for example, for this button. When the user clicks the button, then this function is called. Okay, a good way of including JavaScript file in HTML is to use this attribute, which is defer, which means that the JavaScript code in this file, which will be included in the current HTML document, should be executed only after the current document is completely loaded. You will probably run into problems if you write code like this in the script tag, in the head tag of the current HTML document, and you write this code which just obtains the object corresponding to a tag with the ID button, like this one, and then it tries to add an event listener, an event handler, so when the click event happens, it should execute this some function. The problem is that when this code is executed, if this code is placed into a script.js file which is included in this script tag, which is placed in the head part of the current HTML document, then when this code gets executed, the current HTML document is not completely loaded. So this button doesn't actually exist, because this button is specified later on in the body part of the document. So this one would be null here, and this would throw an error. JavaScript would throw an error here because you cannot call a method on a null object. Okay. In order to solve this, the old way was to place the script in the bottom part of the body, so the last part of the body tag in the HTML document. But a better way is to use this attribute defer, which prevents the JavaScript engine from executing this code before the current document is completely loaded. So it's a very good idea to use defer. We can use pop-up boxes in JavaScript either for debugging or for confirmation from the user. We can also use console log for debugging. This one just displays a pop-up window with this text and an OK button. This one displays a pop-up window with this text and an OK and cancel button. And this one displays a text and a default value, and it allows the user to input a value and then click either OK, which returns the value, or cancel, which returns null. Now we move to the document object model, DOM, which is just a standardized hierarchical model of HTML and XML documents. It is standardized by the W3C consortium. The DOM object model, the document object model, is used for navigating into the document structure of the currently loaded HTML document, for modifying the document structure, for adding, deleting, modifying child elements, and also for modifying attributes of the current loaded HTML document. Each tag in the current loaded HTML document has a corresponding object in the DOM. The DOM, the document object model, has an API which can be used in JavaScript in order to manipulate it. And JavaScript plus the document object model is sometimes called dynamic HTML, DHTML, because you can change the current HTML document using JavaScript through DOM, through the document object model. Okay, this is a picture of the hierarchical DOM structure. So we have the document, which is the root of everything. Then we have which is the object root of the document object model. Then the first the child of this document would be an object corresponding to the HTML tag, which is the root. This object has two children. One object corresponding to the head tag and another object corresponding to the body tag. They are all elements. And then this object has additional children and this object has additional children. One object for each tag present in the current HTML document. Actually, there are objects corresponding to text nodes like this one. So this is just the inner content of this heading one. We still have an object corresponding to that one. These are elements, these ones, and these are nodes. Okay. Well, actually, elements are objects that correspond to tags, but they don't have objects corresponding to text and comments, and nodes are objects corresponding to tags and to comments and text nodes. So an element, so nodes, a node can be an element, but an element is not necessarily. Nodes actually includes elements. The DOM browser objects are the window object, which we can use in order to manipulate the browser window, the navigator, which is still the browser window, the screen, history, and location. Location is the current URL loaded. History includes all the URLs that were visited before, and screen is still the whole browser window. The DOM document objects are document object, anchor, area, base, body. So this is an object corresponding to body, this is an object corresponding to a button, this is an object corresponding to event, to a form, to a frame set. This is corresponding to input, and there are several other DOM objects that correspond to each single tag type, but they are not listed here, so this is not a complete list. some a selection of the collections inside the document object. They are not all of them, but it's just a selection. So it has the document object, the default document object has a list of forms, a list of images present in the current document, a list of anchors, links present in the current document. Sorry, these are anchors, and these are reference to area and link objects. Then some properties of the document object. We have this body property, which is an object that corresponds to the body tag of the current HTML document. Then we have cookies. These are useful for conversation with the server, with an HTTP server. We will use this when we talk about server-side programming. The domain of the URL, the last time the document was modified, the referrer, if we got to this document through a search engine like Google, then this referrer will be google.com. The title of the current document and the uniform resource locator of the current document. This is still a selection of properties, a selection of methods. Close, using this method we can close the current document, we can open a new document, we can write into the current document, write in the current document and move to the beginning of a new line, or we can get from the current document various objects corresponding to various tags. We can get a reference to the first object that corresponds to a tag with this specific ID. We can get the elements that have this the attribute name equal to this one. We can get all the elements of all the objects corresponding to tags, to specific tags. So for example, we can get a collection of all the objects corresponding to all the P paragraph tags in the current document. You will see how we use this in the examples. The element object. So I've told you we have the node object. Every single tag in the current HTML document, but also text, so the inner content of a tag, and also comments. They all have a corresponding node object. All the tags all the tags in the current document, so not the text parts and the comments part, they all have a corresponding element. So the node corresponding to a tag that's not the node, so the node corresponding to a tag, so not to a text part or comments from the current HTML document, this node is actually an element. And there's an element object corresponding to each tag in the current HTML document. Some of the properties that this element objects have are attributes, which returns a list of attributes of the current element. Its children here, the classes of this current element, these are all read-only properties, so we cannot change them. We can change the class name using this one, so this is a setGet property. We can read the client height and the client width, which is the height and width of the current element, including the padding. We can get the first child, the first element child. So this one returns, this one ignores text and comments, as I've told you. We can get or set the inner HTML content of this element or the inner text. Using this one, we can add HTML content, inner HTML content to the current element. And using this one, we can add only text, so not HTML content. We can set or get the ID attribute of the current element. We can get the last child, the last element child. Remember that an element ignores text and comments. Last child does not ignore those. We can get a sibling, the next sibling or the previous sibling. A sibling is just an element which is on the same level with the current element in the DOM hierarchical structure. We can have the same next sibling and previous sibling, but only take elements, so not text and comments. Then we can take the parent node. we can take the parent element. Again, an element ignores text and comment, a node does not ignore those. We can set or get the style of an element, so we can modify CSS properties through JavaScript of the current element. So a selection of the methods of the element object. We have add event listener, remove event listener for handling event for adding or removing event handlers for the current element. We can add children or remove children to the current document, to the current element. We can simulate a click on the current element. We can get or set an attribute of the current element. We can get we can get all children of a specific with all children with a specific tag name from the current element. We can get all children with a specific class from the current element. We can insert content before the current before the this element. We can insert content after with insert after. We can remove the current element, and we can search for a specific tag as child of this current element using this query selector and query selector all. There will be specific slides about query selector and query selector all because they are very powerful search mechanisms. Yeah. So this one, document query selector returns the first element that matches this CSS selector here. We can have one CSS selector or a list of CSS selector, in which case it returns the first element that matches any of these selectors. Okay, so this one, document query selector, will return the first element, will return the object corresponding to the first tag that has the ID first in the document. And this one, query selector or, does not return the first element, but all the elements that that verify this CSS selector. So it returns all elements that have the class equal to first or the class equal to second, and they are paragraphs. These are very useful in order to navigate through the DOM structure, these two methods. Some examples that create and remove elements or tags dynamically. If we create or remove an element, then the actual tag corresponding to that element object will be added or removed from the HTML document. So here we create a paragraph dynamically, and we create a text node. Remember that an element is just an object associated with a tag, and a node, it's just an object associated with a tag or with a text content or with a comment. And we create a text node like this, and then we set the inner content of this p object of this paragraph to be this text using append child. We can modify this inner content by setting the inner HTML property to this. We can clone this paragraph, and we can insert this p1 before this paragraph, and then we can remove this child, which is the first child of this p, which is actually this text, and then we can remove the whole paragraph object using this. So hopefully you've understood this. Modifying elements, we have here we get a reference, we obtain a reference to a section, to the first section tag from the current document. We can set the attribute of the section, we can set the class attribute of this section to red section. We can modify the CSS style, the background, just specify that the background color will be red. We can set the inner HTML of this section to be this. So we create a child paragraph element inside this section, and then the paragraph would have this text as the inner content. Or we can set the inner text. Remember that the inner text does not allow us to, use HTML code inside it. Okay, now a little bit of asynchronous programming, and then we'll move to examples. So asynchronous programming in JavaScript, it's a sort of parallel programming. It's not quite parallel programming because JavaScript code runs on one single thread inside the browser. Of course, the browser has some other threads which are associated with tasks from the JavaScript engine, but the code written by the programmer runs in one single thread. So it's not that easy to do parallelism. But you can do asynchronous programming, which leads to more efficient, more optimized code execution. I will tell you more about asynchronous programming at the end of this lecture. I have a specific, let me show you. I have here specific tutorial on this, and I'll tell you more about this when we get here at the end of the course. Okay. But for now, just an introduction. This timeout, which is a function of the window object, which is a default object representing the whole browser window, this one executes this function after this specific delay, which is expressed in milliseconds. And these are the parameters of this function, okay? And it returns a timeout object, which can be used in order to cancel it, okay? To cancel the timeout, so not execute the function if it's not already executed. So what happens here is that this task would be placed into a different thread, a thread of the browser. The code following this window set timeout will keep executing, and then after this delay interval has passed, then this function will be executed by the browser. I'll tell you more about this when we get to this file, okay? Here we have a detailed explanation of Windows set timeout and promises. Okay, we can also do asynchronous programming using promises. When we create a promise like this, the parameter of a promise is an executor which needs to have two parameters, a resolve and a reject. They are both callbacks, they are both functions. They are created by the JavaScript engine, and we do some asynchronous work here. This work is performed in the constructor of the promise, and when we end with this work, we either resolve the promise by calling this resolve function, or we reject the promise by calling this reject. Okay, all this code performs asynchronously, meaning that it is performed in a different thread than the JavaScript execution thread. You'll see more about this in the examples. And the return value of the promise is ignored. But in order to get the value from the promise, we need to use the then construct at the end of this promise, but you will see that in the examples. Actually, yeah, there is an example here. Let me try to zoom in a little bit. Okay, so here we have a promise. The work that's the asynchronous work that's performed in this promise is just this print. It's not that asynchronous. Well, it is asynchronous, but it's not. This print does not justify doing the asynchronous work. So the work is just this print, and then at the end, we consider that this promise executed successfully, so we resolve it using this by calling this resolve callback function with the parameter done. We ignore reject, so we assume that the promise is always resolved. The thing is that we cannot get a result from the promise. Promises cannot return anything; they just pass results to callbacks, like this one or this one, which are then specified using this then construct, like here. So after this promise is executed, we can get the result by specifying the resolve parameter and the reject parameter of the promise. Okay, this is just the resolve parameter, so we ignore the reject. We consider that the promise always resolves. And this is the resolve parameter of this promise here. So when in the promise, when we call resolve, we actually call this function, which just prints this result, which is done. Okay. Let me show you. Let me quickly show you that I have this example. Don't think I need this anymore. I have this example is also specified here, so everything, all the asynchronous examples are here, but I also have them locally for convenience. Let me see here. So that example I think is in this one. This, maybe I should open it here. I don't need this anymore. Let me open it here. Let's see if I can open all of them. Well, not quite all of them. I don't need, and that one. Okay. Okay, so now I'm at this one. Okay. Let me add this code inside the body so that we see here what happens. Okay, save it and reload it. I should add them in a pre tag. Pre tag, okay. Pre and code. And then code and pre. Okay. Okay. Now it looks better. Let us see the web console. So what happens here is when we call this when we create this promise, this code will be executed so that doing some work gets printed, and when it's done we call the resolve parameter, which is this one, and actually it is specified here, the resolve function using then. So this resolve, again, I remind you that we ignore this reject parameter, so we consider that the promise is always reserved, so we don't specify a reject function here, although we should have. So after the promise is resolved, this resolve function, which is an anonymous function, is called, this is the resolve parameter here. So it is called with the parameter done. That's why we have this print done here. Okay? After the work is done. Okay? I will show some other examples that do something else before that do something else after this promise is created and before this then is called here, to see that this code is actually asynchronous. But this is just the first simple example. Okay, let me undo what I've just done. Maybe, yeah, let's leave it this way. Go to the presentation, back. We only have a couple more slides. Sorry. Doesn't look very well, but I think we can. I only have a couple of more slides. There's a problem with JavaScript and browser compatibility. There's a problem with JavaScript and browser compatibility, and that's it's a similar problem we had with CSS and browser compatibility, but it's more complicated. With CSS, remember that different browsers have different default styles, and in order to have the same view on different browsers, we need to use a CSS reset or reboot package, which basically Bootstrap has one of them, and there are several reset packages which just reset the margin, the padding, the borders of all the elements with the same value for all the browsers, so that we have the same view in all the browsers. For JavaScript, we have a similar problem, but it's more exacerbated. since some browsers implement different versions of ECMAScript, we can have the JavaScript code that we wrote for a specific version of ECMAScript. This code may not run in all the browser, in which case we need to use polyfills, which are just JS libraries that extend the functionality of the browser, like core.js or polyfill.io. And we need to use transpilers like Babel, which just takes a higher ECMAScript version code and converts it to a lower ECMAScript version code. Let me. Oh, okay. Yeah, it was zoomed out. Now this is the end of the slides. Well, actually, I think I still have one more slide. JavaScript can be a very powerful language, a messy one, and a language full of drama. There are people that hate this language. There are people that love this language because it's fast, it's dynamic. The language it's quite complex, has a lot of problems. A few of them are listed below. So some Java quirks are listed here. To see a longer version of this list, you can check this URL or some other. There are a bunch of URLs that details the problems of the JavaScript language. Many of them are related to the implicit type conversion, so the automatic type conversion system. For example, this is 0.5 plus 0.1 is equal to 0.6, which is true, of course, but 0.2 plus 0.1 equal to 0.3 is false. This is due to the way that numbers are represented. They are all double numbers and they are approximated. But of course, this is a mistake of the language. And another one is type of none. None means not a number, is a number. Then here 3 plus 1. Here 3 is automatically converted to string, and the result is the concatenation of both strings. But here, if I use the minus, this is automatically converted to a number, and the result is 9. If I check that true is automatically converted to 1, so it is equal to 1, but they have different types. And if I do this identity, if I use this identity operator, then true is not identical to 1. If I add two empty vectors, I get the empty string. So there's a lot of quirks of the language. Something about browser API, web API, JavaScript libraries, and JavaScript frameworks. Because this is the largest lecture on JavaScript, my largest lecture on JavaScript, but we'll still talk about JavaScript in the following lectures. We will introduce jQuery and WebGL and WebRTC, which is also JavaScript, and then Angular. So we need to make sure that we understand some base concepts in the JavaScript realm. So we have the browser API, which is a set of JavaScript functions, objects, and properties exposed by the browser. An example is the document object model, but there are also others, and a list of available browser APIs are detailed here, the World Wide Web Consortium page. Then Web API is a server-side API, usually exported through HTTP request response. The response is usually a JavaScript object notation expression. You will encounter REST Web API a lot of times, especially in this other course that you have in parallel with the web programming MPP course. This is executed at the server-side web API. A JavaScript library is just one or more JavaScript files that provide custom function and objects that enhance the functionality of the JavaScript language. An example is jQuery. And a JavaScript framework is also a JavaScript library. It can have additional HTML and CSS code useful to write an entire web application from scratch. So the difference between a JavaScript framework like Angular and a JavaScript library is the inversion of control, meaning that when calling a method from a library, the developer is in control, like in jQuery, but with frameworks, the framework calls the developer code using callbacks, so the control is inverted. So we end the slides by presenting you some debugging tools that you can use: the Firefox Web Console and Chrome Inspector. We've already used the Web Console in Chrome, the inspector in Chrome, and you can use JS Fiddle and CodePen, which are just text IDEs online that you can use in order to write JavaScript code. Some additional documentation are this one for the documentation for my course. Then the pages from W3 schools, and one very nice documentation page is the Mozilla Developer Network, so the JavaScript documentation at Mozilla, which is very complete and very good. And then there's also a Babel course on ES6. Okay. This is the end of the lectures. I don't know if we need them. Let me leave them like this. Let me continue with the asynchronous tutorial, and then we'll get to explaining well, or no, maybe let me explain first the examples that we have here. I have here a puzzle example, so simple drag and drop, a sortable, this test browser, and an example of validation. I also have here I have here the presentation 5, which is the JavaScript library and CSS that I'm using in order to do this lecture presentations, this ones. Okay. So this is done. This is like a PowerPoint but online, and this is done in CSS and mostly JavaScript. So I have a is this library, this one, presentation 5. So just an HTML file with the presentation, a JavaScript file. Most of the work is done here, and some CSS file. This is for code. This Sandburn for code, but it's not that long. And this is for transitions from one slide to the other. I have several types of transition, concave and convex. The default one is convex, which is this one. For moving from one slide to the other, you had the impression that they are organized in a sort of a circle or a part of a circle. Okay, I maybe we'll talk a little bit about this too at the end. But first, let me show you the simple example. So I think the simplest one is this one, which just displays the type of the browser. I think this one is wrong because mine is Chromium. Let me see the source. Yeah, so it just prints the value, the property application code name of the navigator. But I don't know. My browser is Chrome. So yeah. Let me show you this one with its validate. I think it's so. We are not allowed to insert more than 5 characters here. Let's insert 5 characters or 4 characters first. Okay, doesn't do anything. So let's insert 6 characters, in which case it tells me that do not insert more than 5 characters. Let us see the source code. Remember that client-side validation is useful, but it should be complemented with server-side validation, because due to security reasons, because the client side is at the user disposal, so you can do whatever you want here. For example, yeah, I can just inspect this, okay, and I go here and here, and I go here into this code, and then I change this. Sorry, I changed this so that 6 would still be valid. Okay, it should work now. Sorry, let me. I think I need to reload it. But if I reload it, this would change. Yeah, but anyway, no, it does. But anyway, I can add this HTML. I can download this HTML document locally. I can change this and run the HTML document locally and then send to the server. Okay. Let me show you the code. So what happens here is that I have this form with one input of type text, this one, and one input of type submit, which submits everything. It doesn't matter now, but it will matter when we get to server-side web programming. And on submit, so the on submit event, sorry, on the submit event, the on submit event handler is this code, which is return validate, and the validate is this function which just gets a reference to my form, which is this one, so the object corresponding to this form, and then we get a reference to the input, which is x, which is my form, my input, and the value of the input. My input is this one, and the value of the input is value. And if the input length, which is so if the value of the input, which is a string, its length is larger than 5, I just show this pop-up which prints this text and then returns false. Otherwise I return true. If this function returns false, then this form is not submitted. But you probably don't know what is form submission. You'll understand this when we get to server-side programming. So this is form validation at the client side. The next one is a sorted table. If I click this column, the table will be sorted ascendingly. Okay. Let us see the code. So I have here the table, and when I click the table, it calls this function sort with the value 2. Let's see what 2 means. 2 is actually the column, I think. It has here a default column. So this function sort, what it does is it gets, using the query selector, I've told you that query selector is very important. It gets a reference to the table object corresponding to the tag with the ID myTable, which is this one. Okay. Yeah, this one uses bubble sort. Okay. So while the table is not ordered, sorry, while the table is not sorted, while switching is true, we set it to false and then get all the rows of this table object. Okay, the rows are this ones. This tr, 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 and trs. Okay. We start with index 1 because we don't want to order this table row, which is the header of the table. This header, we don't want this one to be, sorry, call 1, call 2, and call 3. We don't want to move this. The header of the table should stay the same. And we go to rows length -1 because we will use here because we use here the index I plus 1. And we get the value of the TD cell from rows index I. So this one gets all the TD elements, the TD child elements of this the eth row, and we get the TD, the table data, from this column, which is here. In our case, is column 2 because I've called it with column 2. And we do the same for the next row index I plus 1. We check whether the inner HTML of table data X converted to lowercase is larger than the inner HTML of table data Y converted to lowercase. If it is so, we just switch them. We just switch them. Okay, here. If we should switch, then we get the parent of rows I, and we insert before rows I plus 1 rows I. So we move the content of rows I before rows I plus 1. Okay, the parent is the table. The parent of the table row is the t-body. Sorry, is the t-body. So in the t body here, we insert before rows I plus 1 rows I, and set switching to true because we just the table is not ordered, so that this while should be executed more. So it's just classical bubble sort. And again, if I click a column, then everything would be sorted according to according to column 2. Okay, so 1 for D. Actually, I think, yeah, it's this one. Column 2 is this one. This is column 0, 1, 2. Okay, it's this one. So it is sorting according to the values of column 3. Okay, next example is this simple drag and drop. This is just an image, and we can take it by clicking on the left button of the mouse and holding the left button pressed, and moving the tag around, moving the image around with the left button of the mouse pressed, and then releasing the left button of the mouse so that the image stays here. Yeah. The source of this is the following. In order to move it, we need to set position absolute so that it can move. Otherwise, it doesn't move. And these are just some other CSS properties, not very relevant. I'm using this an image, and the script that performs this is maybe I should open this. Yeah, maybe I should use the Sublime ID because everything is colored here. But I didn't download these examples, but we can also open them here. So okay, so I have them here. And so let me open this one and this one. Okay, so this is drag and drop. What I'm doing here is get a reference to the drag one element, which is this one. Okay, and then I add an event listener when the mouse bottom is down. So when I click the mouse button, when I press the mouse button, this function will be executed. lm mouse down. Okay, and this function is the following. We use this prevent default because the browser has a default action when pressing the mouse. We want to avoid executing the default action and just moving the element. And then when I click the mouse, when I press the mouse button down, I add an event listener for the mouse move, and this function gets executed. Wherever I move the mouse across the document, I add this mouse move. Okay. In the mouse move, this is the event object. I take the page X and page Y, which are the coordinates on OX and OY axis of the mouse. I take them from the event and I store them here. I modify the style of the drag element, which was saved here, which is just this image. I modify the coordinates, the left coordinates, through the style, the left and top, through the style property of the drag element, so that I set them according to the current positions of the mouse here. And then I add a new event listener for mouse up, because when I'm releasing the mouse, the left button of the mouse, even if I then move the mouse, the image should not move anymore. Okay. So I'm adding this event listener for mouse up, event mouse up, which just removes the mouse move. So this code does not get executed anymore when I release the mouse button, and also removes this mouse up. Okay, removes this event listener for raising the mouse button up. So this is how we do simple drag and drop with mouse down, by handling the mouse down, mouse move, and mouse up event handlers. Close this. let me show you this other example. I have these images from Lena. And well, I have another example here. Let me see the source of this. So this one, so I have a paragraph, a button, and a div, and here when the window is loaded, so the onload event of the event handler of the load event of the window is this anonymous function which ends here. Okay, so I get a reference to this button b1, this one. Then I add an event listener to this button, so when I click the button, this anonymous function gets executed. And I get a reference to this paragraph, which is this one. And what I do is just color the background of this paragraph with this color. That's why we see this blue. Okay, if I click this one, it will color this with blue, and it also creates this button. I think it creates another button here. It sets the attribute ID to button2. It adds the type text, the inner HTML button2. That's why we have button2 displayed here. Add the style display block and add an event listener, this function, and then append to the body. Okay, so that this button appears here. And the event listener for click is this function, which just when I click this button, it just displays something on the console and gets a reference to this div and removes this div containing text. Okay, so if I click this one, the text will disappear and I'll probably see something on the console. So the text disappears and I see click to. Okay. Okay. Now let's go to this. This is just a no, sorry. Let's go to the puzzle, which is just a puzzle. This is a picture of Lena chopped into small pieces, and I can move this in order to resolve. I can move this around in order to resolve the puzzle, but it's a bit complicated to resolve it. So I'll just show you the code. The code doesn't check whether whether the puzzle is complete. It just moves on mouse clicks. It checks whether we have this empty box here, and it moves the image that I've clicked on into the empty box, and the empty box replaces the initial position of the image, the clicked image. Okay. Let me show you the source code. The source code is here. So I can remove this. I have this body and this table, which initially doesn't contain any image. The table doesn't contain any image, but it has some IDs. The table cells has IDs from 1 to 25, and when the user clicks a cell, this function gets executed. Move with the ID of the cell and this object. I think this ID is not required anymore because we have this object, but anyway, this is old code of mine. And when the body tag is loaded, we call this function load puzzle, which just places the images randomly in this table data cells. Okay, let's see the load puzzle first, the load puzzle function first, and then the move function, and that's it. So the move function is here, but let's see the load puzzle first. Some style information, not that important. We need to store the position of the empty cell. Right now it's 25, so the last position. And the load puzzle picture just constructs an array of images, and it goes from index 1 to 26. I don't remember why we Yeah, I don't see any reason to start with index 1. We could have started with index 0 to 25. For some reason I started with index 1. So what we do here is just generate here a random number between 1 and 25. Okay. And we do this 26 times. Sorry, 25 times because we have 25 boxes. But when we generate this one, it may happen that we generate it may happen that we generate the same number 2 times. Okay, so we generate first the number and then we search this number in this pix vector, which stores the random numbers already generated so far. If we found a number, okay, we resume this while cycle and generate a new number again until we generate a number that is not in the pix vector, okay, which is initialized here and it's empty here. And then after I've generated a number that is not in the pix vector, then we add it here, okay. We add it here to the vector and to position I, and if x, the random number generated, is 25, then we also set the empty cell to this position. Okay, the empty cell holds, again, the empty cell holds the position of this white box, okay, which is random in the beginning. Okay, it's here. And if I do this again, it's here, okay. Then we need to populate the table with the images, and the pics are just the IDs, the random IDs of the image or of the images which populate the table. So again, we do this for cycle with I from 1 to 25. We get the element by ID, so we get a reference to cell. Let's say so cell is first, I is first 1. So we get first a reference to the first cell, this one. Then we get a reference to the second cell, this one, and then the third one, and so on. Okay, so first we get a reference to cell number 1, and then we set there, or we add the pix1 picture to that element as child of that table data. If this has value, then we create an image element and we set the attribute, the source attribute of that image. Sorry, we set the attribute of that image to be Lena plus pixi, which is the random number that was already generated here, plus JPEG, because we have all these pictures here. We have this Lena 1, JPEG, Lena 2, JPEG, Lena 3, JPEG, Lena 4, JPEG, until Lena 25 JPEG. Okay? One of these is the... yeah, no, it's empty JPEG. This is the white box, the white picture. Let me load this again. Okay? We don't need this anymore. Yeah. Yeah, here. Okay, so we create an image. If this index I is not the index of the empty cell, then I set the source attribute of that image to a random part of Lena. If it is equal to the empty cell, then I set the source attribute of that image to empty. Okay, and then I append the image to the cell which is obtained here. And I do this 25 times for each cell. First for the first table data cell, then for the second, and for the third, and so on. And then the move function, which happens here when I click the move function, which happens here when I click one table data, is here. So what we need to do here is check whether I've clicked an image that has this white box among its neighbors. So if I click this image, which doesn't have the white box as its neighbors, it doesn't do anything. Okay, but if I click this one, which has the white box on the left, then it switches this image with the white box. Okay, or the same here, and the same here. Okay. So first I need to check whether the white box is a neighbor of the current clicked image. And I do this here. I know this the cell ID of the cell I'm clicking. Some print here. I check whether I click the empty cell. If I click the empty cell, I don't do anything. And then I check whether the image that I clicked is on the borders. So I check the top position, the bottom neighbor, sorry, the top. Sorry, this is the top neighbor of the currently clicked cell. This is the bottom neighbor of the currently clicked cell. This is the left neighbor, the right neighbor. I check whether any of this is the empty cell. If not, if all of these are not the empty cell, then I return because the empty cell is not a neighbor of the currently clicked cell. And then I get a reference to the empty cell. I already have a reference to the currently clicked cell, which is this one. And I just switch the images from cell 1 and cell. Okay, so I get the first child, which is the image of cell 1. I get the first child of cell, which is the currently clicked cell. And then I remove the child, the first child from cell and the first child from cell 1, which are just the images. And then I append img1, which is from cell 1 to cell, and then I append img, which is from cell to cell 1, and that's it. And I set a new position for the empty cell, and that's it. Okay, so this is with the puzzle. No, do not save it. Okay, now let me tell you about, let me go back to asynchronous programming here. I've shown you, let me show you the timeout example, which is, well, actually I think I'll load it here. I've shown you this promise example. Let me load the timeout example. This does something. We already have it here. Yeah, let me also place the code here. Well, I don't think I have enough time to show you all. Or okay, let me show you this one also. Let me comment this one out. Let me uncomment this one. Okay. Let me copy this so that we can actually see the code. We need a body. Okay, and then we need a pre-encode code, and then okay, and let me just paste this and do some indentation. Okay, let's save this and load this into the browser. So what happens here is I've declared a function here and I've called this function here. Okay, when we call this function, what happens is that A gets printed here. Then I execute this function called display, which just prints the value of B with a delay of 0 seconds. So this should happen instantly. But because the functions set to be executed with setTimeout only get executed when the current JavaScript stack is empty, which is not empty due to this function. This B, even if the delay is 0, this B gets not printed here, but instead this C gets printed, and then B is printed. Okay, so even if I've written here display B before or console log B before console log C, because this is executed in a timeout, in a set timeout, even if the delay is 0, this delay is actually the minimum delay. So the actual delay after which the function gets executed can be larger. As you see, this B is printed after C. You will understand more about this when I present you this tutorial in a minute. Let me uncomment let me comment this part and uncomment the second example. So here. Okay, and the second example is this one. I also need to copy this. Okay, I need to copy it here. Yeah. And yeah, let's save it and try to run it. So reload. Okay, so we see ACB. Let's see now the code. So I have here this main function, which is almost the same function as before. It has a console log here. I call it here. Okay, so the function is called here. It has a console log here, then a set timeout, which executes this function, which just prints a B with a delay of 0. Then it executes this and then prints C. This run while loop for 3 seconds is this one, which just gets the current time and then it keeps getting the current time and it keeps executing this while for 3 seconds. By the way, this is a very bad idea to keep the JavaScript thread occupied with this code. So this is a very bad idea, very unoptimized, very non-efficient to keep the keep the Java thread occupied with unimportant work. But it's just an example. So what happens here is that A gets printed first. Okay, A gets printed. Then because of this timeout, this console log B, even if the delay is 0, doesn't get printed until the call stack, the JavaScript call stack is empty, so it doesn't get printed. Then we have this wait for 3 seconds, which you've seen that when I reload this happens. So the document or the browser is working for 3 seconds, and then it prints this C and again this B, okay, which is the last one. So even if you write set timeout a specific delay here, this delay is just the minimum delay. It may happen that the delay is longer than this, after which this function gets executed. Now let's move to this tutorial so that you understand better what happens when we execute set timeout and also when we execute promises. As I said, the Java interpreter in the browser is single thread, although there are several other threads available in the browser, so that sometimes the execution is parallelized. Synchronous code is just a piece of code that blocks the execution. Nothing gets executed until that piece of code completes. For example, here, okay, so this is if I write, let me just modify this. So if I write something like this is a synchronous piece of code because AA will always be printed after A. So okay, so printing A blocks the execution of this AA. Okay, so this is synchronous code, this one. But this one is asynchronous code because while this is postponed, or while this sleep happens for 0 seconds here, this code gets executed. Okay, so this code gets executed while this code gets executed while this code waits. This is asynchronous execution. Asynchronous code is a piece of code that does not block the execution. Other code can be executed until the asynchronous piece of code completes. And this is not necessarily parallelism. In order to have parallelism, we need to have at least 2 threads. So when this gets executed, so when this waits for 0 seconds to pass, okay, this is not quite a good example, but I've told you that it actually waits for more than 0 seconds. So while this waits for execution, the execution is not blocked like this one. This one blocks the execution. Nothing happens until this is done. So this is synchronous execution. It blocks the execution. But while this waits, the next code can be executed. So this is asynchronous execution. Okay. We need some concepts here. So the heap in the JavaScript engine, the heap is a memory space of the JavaScript runtime, JavaScript engine, where all JavaScript objects are created. Then we have the call stack, just like similar as we have for other programming languages. The call stack is used for function calling, for placing the parameters, the return address. So whenever a function is called, just like in other programming languages, just like you know from the assembly language, a stack frame is created, is allocated on the stack for this function with the return address, with the arguments of the function, local variables, and so on. Then we have a task queue, which is used by promises later on, which is just a first in, first out queue, where tasks are added and executed one at a time. Sorry, this task queue is actually used for set timeout, but it's very important that the tasks are extracted from this queue only when the JavaScript calling stack is empty. You'll see an example here, graphical example. And then we have the browser API, which are functions that are outside of JavaScript runtime, and they get executed by other threads in the browser. Like the DOM events, the local browser storage, the AJAX request, the set timeout, the console log, and so on. Let's see an example. So this is an example of synchronous execution. We have this function, test function, which just prints function test on the console, and we call it here. And then after calling it, we'll just call this other console log. So the result would be that this function test will be printed first on the console and then an example, which is specified here. The way this execution happens is the following. So we have here the calling stack, which initially is contains the test function here. Okay. Initially it contains initially is empty, then it adds the test function, it adds a stack frame for the test function, which is this one, console log function text. This console log function text gets printed, and then this test is removed from the call stack. Then this console log end example is added to the call stack here. Okay. And then this gets executed, which prints end example, and then the call stack is empty. Let me show you another example with asynchronous execution, which is this one. Here, well, maybe if I zoom in a little bit, maybe it's useful. Here I have the same example as before, but instead this function test is not executed synchronously, but it's executed with a delay of 1 second, 1000 milliseconds. Okay, what happened? And the same code for test and the same for this console. What happens here is that the result is reversed. First this end example is printed here, and then function test is printed here. Okay. Here we had function test first, and then end example, and this is the reverse. End example, and then function test. And what happens here with the same calling stacks? So we have here the calling stack, okay, which just we add set timeout on the calling stack because this is the first function that gets called in our JavaScript code. It's added here. What happens here is that this waiting action is moved to the browser API here. So the calling stack is empty, and then we add the second function call, console log, on the calling stack here. Okay. This waits for 1000 seconds. Even if we had a delay of 0 seconds, it would still need to wait because this gets executed only when the calling stack is empty. Okay, and now it's not empty. So now the console, this one prints end example. Okay, it prints end example on the console, so that the calling stack is empty. Okay, now we add the test function from the browser API, a thread which waited. We add it to the calling stack, and the test function calls this console log function, and we add this console log function, a stack for this console log. The browser API is empty. Sorry. Yeah. So the browser API waits 1 second for executing this test function. After waiting 1 second, it adds this test function to the task queue. Okay, here it adds that to the task queue here. Because the stack is empty here, because console log and example already happened. Now the browser or the JavaScript the JavaScript engine takes the test function from the task queue and adds it to the calling stack. And then the console log, which is from the test function here, is added to the calling stack. And then the task queue is empty, and then they get executed so that they print so that it prints a function test. Okay, the above example is asynchronous, but it's not parallel or concurrent, because the function test is executed only after this console log took place. The function test got removed from the task queue only when the calling stack was empty. Okay. But if instead we had an AJAX request, that would be truly parallel, because the AJAX request is executed in another thread, but you will see more about that when we get to server-side programming. Let me show you an example of promises, because these are faster than set timeout. So what we have here, so we have here the same function test, which just prints test. Then we have this function text, which is executed with a delay 0, and then we have a promise, which is declared here using the classical functional specification, but instead here we have this this fat arrow notation here. Okay, so this code is the same as this one commented, but in this commented code we have the function, the classical function specification, and here we have the fat arrow notation. So let me comment this one, and then at the end we have a console log example. What really happens here is, well, let's see, this test this test prints function test with a delay of 0 second. Okay, then this promise prints this promise prints this promised result, and then we have end example. Okay, and surprisingly in the output we first have the last print specified here, then we have promise resolved, which is this one, the second one specified, and lastly we have the first print, which is the one specified here. So this is this is tricky. So this is not intuitive. Normally we should have this print first because the delay is 0 second. Then we should have this one for normal execution, and then this one because it's printed at the end of the JavaScript code. But instead we have the reverse. First is this one, the one specified last, then the one specified second, and then the first one, due to asynchronous execution. Why this happens is that, well, this set timeout just places the test function on the browser API to wait for 0 seconds, okay? And then it is moved on the task queue after 0 seconds, okay? But, so that's why we don't have this function test printed before end example, because this one waits until the calling stack is empty, and the calling stack is empty only after this is executed. But why this promise result gets printed is because promise gets executed before timeout, even though set timeout comes before the promise in the code, and the delay of set timeout is 0. And this is because a promise is not placed on a task queue, but they are placed on another queue called a micro task queue, and they are taken from this queue as soon as they are resolved. So it doesn't wait until the calling stack is empty. Okay, so So this one, so the test is, as in the previous example, the test is taken from the browser API and placed into the task queue, but it gets removed and removed from this task queue and executed only when the calling stack is empty. But for the promises, we have a different queue called the microtask queue, and the promises that the microtasks get removed from this microtask queue even when the calling stack is not empty. And that's why the promise gets executed before the set timeout, okay? And the promise is this one, so it has this resolve and reject parameters. We assume that the promise is always resolved. It just sets a variable and then calls resolve with this parameter, promised resolved. And here, so this code, which is the executor, gets executed when we construct the promise object. Here we specify after the code is executed, we specify how to get, we specify the resolve function, meaning how to get the return result, which is this string from its return result, just gets printed here. So this is the resolve function, and this is the reject function, but we assume that promise is always resolved because we don't call the reject here, okay? So the actual how we get the return parameter of the promise is here through this resolve function. What we do with the parameter with this promise resolved is this param, and it gets printed on the console. That's why we see promise resolved here on the console. Hopefully you've understood this. I have some other examples. Here. I don't know which one to show because there are more examples. So I have this promise 1 and promise 2 here. I think I'll skip over this ones, and if you are interested you can look at them at home. Let me just show you the code. So let me undo this and also close this. Let me close this actually and don't save it. So promise 1 is this one, which shows you what happens if you mix set timeout. It's a more complicated example with one promise that gets chained to some other, but this is not a promise, and get chained to some other code here. So I'll just skip over this one and leave you and leave this as a homework, leave for you to study at home. Also this one, which is also a tricky example. Let me discuss this one, which is not that simple, but it may be more useful. So I have this modal dialog HTML, which basically does this. It displays a dialog, it awaits for me to print a value, and then it returns the value. I think this is useful for the console. Here, let me reload it and clear the console. Click one and continue. Okay, so what happens here? We have a bunch of chained promises. So we have, you should ignore this. This is jQuery code, but you should ignore it. This basically means that this code happens only when the document is fully loaded. So what we do here, we call this function, which is described in this JS file. I don't need this anymore. Or maybe I need that one. I don't need this anymore. Okay, this calls this function, which returns a promise. It sends 3 parameters to that function, and then after this function gets executed, we execute this function which obtains the result from this promise. Okay, and the result is the chosen value, which is displayed lastly in the browser console. That's why this text you have chosen and the chosen value is the last one displayed. Okay, you have chosen and value 1 because I chose 1. Let me show you now how this is implemented. This is actually a function which is dynamically added to the window object. The window object is a default already declared object that exists in the JavaScript engine, and it is associated to the browser window, and I augment this object by adding a new method. I've told you it's possible to add new method and new properties to existing objects. Okay, and the way we add this function is in this JavaScript file, show model dialog here. I have this two functions which just this one just append. This is jQuery again, ignore it, but this appends, this actually creates this, it creates this small window. Okay, adds two checkboxes and text label and two buttons. Okay, sorry, let me show you again. No, let me pick one and okay, value 2. Sorry, no, we are here. Okay, so it just adds a heading with that label and two input, two radio buttons, and the OK and cancel buttons are already there. Okay, and this function just gets, using jQuery, gets the value clicked by the user. Okay, and it returns that. So ignore the $jQuery for now. There will be another course on jQuery very soon. Okay, and here I have an anonymous function that gets executed when it is declared. And actually this function augments the window object. It adds a new method to the window object, which is called here, this method, show model dialog 1. Okay, and this show model dialog 1 is this function which starts here. It has 3 parameters. This is an argument of this one, but I'm not using it now. Actually, I use this function for some other project, and that's why I have this argument. But so this function starts here and ends right about here. Okay, what it happens here is, well, a print in window show model something. This is just a print. This is not asynchronous. It's not executed in a promise. That's why this in window show model, you see this as the first print here. Okay, yeah, the first print is this one. And then go here. We create a promise here with those parameters, the 2 parameters. Here is just jQuery code, but this jQuery code just creates a dialog window here. And if I click the continua button, I just call the reserve and I print this one on the console. If I click the cancel, I print this text and call the reject. Okay, and these are further settings of the dialog box of jQuery. Okay, so this is the whole promise. Okay, so this is the promise. It goes from here to here. And after the promise, and this is the executor of the promise. After the executor is executed and either resolve or reject is called, we call this function then, which has also a resolve, which also returns a promise, and which has a resolve. This is the resolve function, which gets executed after if this first promise is resolved here. So this resolve with this parameter dialog div is actually this function. Okay, and the reject for the previous promise is this function, which gets executed if the promise is rejected. If the promise is resolved, the parameter is the dialog div, as you see here, this one. And what we do here, we create another promise because we need to, in the main HTML file, we also have a then chain here. So we want this function to be executed if the promise is resolved successfully. So this one returns another promise and calls the resolve after closing the dialog, because you've seen here the dialog disappears. Okay, if I choose this one and I click either this one or this one, the dialog disappears. Okay, this one is due to reject. Okay. I didn't cut, I pressed abandon. I press continue, it works. Okay, so this one removes the dialog and then call the resolve, and the resolve is actually this function, this resolve, okay, which just prints you have chosen and so on. And if I click the abandon button here, then the promise is rejected. Then this function from then is rejected, which also returns a promise which rejects the result. But this promise is then not, we don't have a reject argument here. We only have, this is a resolve argument. We don't have a reject argument here, and that's why we had that exception, this exception. If I'm specifying here value and abandon, okay, we have this paused on, we have this error, this rejection. Let me load it here actually, and let me modify it. So this is the local code, and let me specify here. So the first one function, which is which is here. Yeah, and then another function which does nothing actually. Yeah, empty function. Okay, let me save it and then we loaded this here. So this is the local file, yeah. And now let me hit ban. Okay. So we still have an error. No, we don't have an error anymore. Okay, we press the ban. So it's because of this function. So hopefully you've understood promises. I still have some examples here. Sorry, not here. Here. I still have this one. There's a newer syntax in JavaScript. In order, instead of writing promise, we can write async and await. This one executes this function asynchronously, and this one awaits for the execution of this function, which should be a promise here. Okay. I think that this course was already too long, so you can read this example yourself if you want to. I can quickly, let me set this to reset. Okay, I can quickly try to show you this presentation 5. What happens is it doesn't have too much content, only this one. Okay, and some code. The actual code is here in this JS file, and I've told you that in this CSS file we have all those sorts of classes that perform the gradients and perform this transition by, it's a bit complicated to explain them all. So I think I won't explain the CSS file, and I briefly explain the JavaScript file. Let me load it here because you see everything colored. So let me see where I have the, well, I have it here, presentation 5. So an important part of this is the fact that no matter how much text I add here, it automatically sets the font size of the elements in this list, so that they fit in the browser window, so that I don't have the scrolling. I don't have the horizontal scroll bar or the vertical scroll bar. An example is here. Okay, so no. Okay, so you see here, so everything fits. The font is lower. Okay, the font size of this is larger than the font size of the nested list, and so on. So I have this automatic font adjustment, and this is computed here with the help of a little bit of jQuery. Actually, I'm using jQuery now. I'm using a little bit of jQuery. So it actually takes an element. So this fit text is added to the FN template in jQuery, and this function actually calls. This function just calls adjust font. Okay, it goes from there to there. Okay, that's this function. Okay, is this function. It contains a closure, which is this one, adjust fonts, which gets as parameter an element in the HTML document and adjusts, calls here for each child of its children. It calls adjust child fonts, which is this function, which is also closure, which adjusts the fonts here by, well, here I shrink the new font size with a %, and then I adjust for its children. I adjust the new font size by calling the same function recursively for the children. There's also some exceptions. Here, if I have this class, I need to take the class attribute of an element, and if the class is equal to this one, then I don't shrink the font size, so that I have this examples here. Okay, where are you? Okay, you see I have this span with no font shrink. This span will not decrease the font size. Normally it should decrease the font size because it's in a nested span, so it should have a font size smaller than this one, but I don't want to be that way. Okay, so this is a complicated function that automatically adjusts font size so that it fits the browser screen resolution. After we've done with this function, so this is just a function. It's not called already, okay? But this one starts here, which contains that function, starts here, and it ends here. It's still not called yet. But this function, this large function, fit text, this large anonymous function contains this nested closure, this closure, and then it returns. So the whole code of this function is just declare these variables, declare this closure, and not calling it yet, and then return this. What? This just takes an element which it received. That takes the element on which we called this function. This element on which we call this function. It takes it here, and for each child. This is a vector actually, and for each element of this vector we call this function, which just saves this the current object, and we call the resizer function, which is still a closure described here, and we call it here, and we also call the resizer function if we change the resolution of the screen. Okay, and so the resizer is called here. The resizer just computes this. It calls this function, this fit text, I think, or not. Let me see. Yeah. Now it calls the adjust fonts. Okay, it calls the function adjust fonts, which adjusts the fonts. What happens here is actually I'm taking the contents of the this object and I'm placing it in a span in a container, and then I'm setting a large resolution. Sorry, I'm setting a large font size for the text in this container here, which is, I don't know, it's somewhere the initial font size. Okay, I leave the browser to set, the actual font size by specifying width 100%. And then if the width of the container is larger than the width of the browser window, so it needs a horizontal scroll bar, then I call I call here adjust font so that it decreases the font size here. Okay, it decreases the font size and adjust it here, and I do this iteratively. I call it again if it's not enough, and at the end I also call it again if I didn't check the fonts in the beginning, if I didn't decrease the fonts in the beginning. And then I have another function which has this initializer, which performs everything. Another function start and place slide. And at the end of that function, this function, the top function is the top function. So this one, this whole document contains only one function. This one. And this function is called at the end. Okay. And that function returns an object which is type presentation 5. It has some properties, these are some properties, some methods, which are this ones: initialize, start, next, which are this one. This is previous, next. This is for playing the current slide, play slide. This is start, and this is initialize. Okay, and this object, remember the name of the variable, holding the function fit text. This one is called in the HTML file. In the HTML file, it is included here, and it's called at the end here. When the document is completely loaded, I just called presentation initialize and presentation 5 start. Okay. And this is because by including this file, presentation 5, we don't really need this name actually, because this function is automatically called at the end here. Okay. And then it's quite easy. So a slide in this presentation is just a section. Heading 1 is the title of the slide. Here I don't have any title, but I have it here. So this is a slide. Heading 1 is the title of the slide, and then the rest of the slide is contained in a list or a div. Okay, and that's how we have this. So this is the title slide, and this is a list, an unordered list or a div, and everything is contained in a section. But well, I think it's a bit complicated to explain everything and maybe boring, but you can look it up if you want. The whole code is here in the examples. So JavaScript examples, and here presentation 5 if you want to use it or look at the code. A small note: this is a documentation, but it's outdated documentation. It's still useful, but it's outdated. Okay, so this is the first and the most important JavaScript course. We'll still talk about JavaScript libraries in subsequent courses: jQuery, then Angular, then WebGL, and WebRTC probably. So hopefully you've understood JavaScript. It's quite complex, but it's the most used language in the world, in the most used programming language in the world, in a lot of top charts. So bye for now.